So we are back in the lab today, and we're going to take a look at something you've probably seen before, which is hydrogen peroxide solution that you could get in the store. And if you look at the label, it tells you that it's about 3% hydrogen peroxide solution. In other words, 3% hydrogen peroxide and 97% water. Okay, now this is kind of an old bottle, so we expect that that 3% begins to break down over time. One of the reasons they put it in a brown bottle is because light tends to break down hydrogen peroxide. So we're going to take a look at this and see if we can titrate it with a chemical that makes it undergo a redox reaction, that is potassium permanganate. We can actually analyze and see how much H2O2 is in a sample of this solution. So if you look at equation number 2 that you've been given, that is the net ionic equation for the redox reaction that will happen between potassium permanganate and hydrogen peroxide. We're going to do a titration similar to what we've seen with acid-base titrations. So what we're doing now is we're going to dissolve the ferrous ammonium sulfate in a mixture of sulfuric acid and water. And we're going to use that, we're going to titrate that with our potassium permanganate solution. I'll get this going here. Start swirling that around. And we'll dissolve all of this. There we go. We'll dissolve all of this in there. It'll take a minute or two to dissolve. And we'll go ahead and titrate that with our potassium permanganate solution to standardize our potassium permanganate solution. I think we have a question from a student.
Can you explain why we have to standardize the potassium permanganate solution before we use it for the hydrogen peroxide titration?
That's a great question. We're going to use this potassium permanganate solution to titrate the hydrogen peroxide, but we have a pretty good idea that this is about 0.02 molar, but we want to get a little bit more accurate than that. So potassium permanganate sometimes contains impurities, sulfur ions, nitrogen ions, chloride ions. So what we want to do is test the concentration of this solution with a solution that we made, because we have a pretty good idea of how many iron 2+ ions are in this solution since we just made it, and we measured out the grams down to the thousandth of a gram. Right? So we're going to go ahead and titrate our solution that we're using first and get a really accurate idea of what that concentration is, and then we'll go ahead and titrate the hydrogen peroxide. So the answer, short answer, accuracy. Before we titrate the ferrous ammonium sulfate, what we did, I went ahead and rinsed out this burette with distilled water. Now I'm just kind of clearing it out with some of the solution that we will be using to titrate. So this is the potassium permanganate solution. It's a really nice purple color. And here what I'm trying to do is make sure there's no droplets of water that are going to dilute this solution when I start putting it in. And then I'll go ahead and clear out the valve. I'll do this twice. Again, we're trying to make sure that the concentration that we think we're putting into the burette is actually the concentration that is going into the burette. So I'll rinse this again, and then I'll set it up, and we will start our titration of the ferrous ammonium sulfate to standardize the potassium permanganate solution. Now that we have our burette full of potassium permanganate solution, we're going to go ahead and start the titration into the ferrous ammonium sulfate. You notice that as soon as the potassium permanganate reacts with that solution, it loses color. So we're going to go ahead and titrate this little by little until we see a very pale pink color. And at that point, all the iron 2+ ions have been reactant. This takes time to be patient. At the end of the titration, we will measure the volume of potassium permanganate solution that was used. You'll notice the color takes a little longer to dissipate now, which means we're getting closer to the point where we're looking for. So you see when you have a nice pale pink color, we're going to go ahead and titrate this 2 more times to get a nice average and be able to determine the concentration of the potassium permanganate solution. So in this beaker, we have a little bit over 1 gram of hydrogen peroxide solution. You saw the exact number earlier. We have some sulfuric acid, and we have some distilled water just to add volume so that we can see the titration happening a little bit easier. Looks like we have a question from a student.
Do we need to add a separate indicator for this titration, like in an acid and base titration?
That's a great question. Yeah, in this case, we don't need a separate indicator, right? When we did acid-base titrations, you use something like phenolphthalein or bromothymol blue, an indicator to tell you when something's going from acid to base. Now, in this case, we have potassium permanganate, and the permanganate ions, the manganese ions in KMnO4, are this nice purple color. Once they are reduced to Mn with a +2 oxidation number, and you can look at the equation to see this, they turn colorless. Okay, so it's kind of self-indicating once this solution starts to lose its color. Now, once this solution titrates starts to turn a very pale pink, that means we have completely converted those ions, and now we're just adding more of this. Okay, so we're going to go back to that pale pink color. So in answer to your question, no, we don't need a separate indicator. The ions themselves are different colors, and they will indicate for us. So we'll start the titration. We fill the burette with potassium permanganate solution. And you see that those manganese ions are being reduced and changing color. Now we can go pretty quickly. I have some idea how much of this potassium permanganate solution it would take if that volume of hydrogen peroxide was 3%. I did the calculation. So I have some idea what it will take. We don't normally want to speed up the titration. We want to give it some time. And again, we're looking for that pale pink color. Move this off to the side a little bit. Okay, it's taking a little longer to dissipate. I'm going to go ahead and do a little bit more slowly. we'll check the milliliters of potassium permanganate solution that were used, and we'll repeat this for 2 more trials.